As I presented SQL 19 to many different customers, I found that they're facing many different challenges today if they don't modernize their systems, especially from a data perspective. It's not just about now migrating to a new version of SQL Server. It's about finding solutions to challenges, whether that is trying to reduce ETL, handle performance problems in new, unique ways, look at things like containers, or bring in technology like machine learning. So customers are looking at challenges they have, and they want solutions for them. And SQL Server 2019, I believe, has solutions for many of these challenges. Consider the fact that SQL Server 19 provides some new capabilities across a broad spectrum of different technologies, things like integrating Spark and Hadoop with SQL Server in a new and interesting way. Being able to provide SQL Server on new platforms never even thought of before, including things like Linux, containers, Kubernetes, and even ARM processors. SQL Server continues to dominate the landscape in the industry with proven performance and security and business intelligence, but even providing new capabilities like intelligent performance, which we'll talk about today. And then think about this, SQL Server now being a product from the edge all the way to the cloud in a consistent database engine, a consistent language with T-SQL, and a consistent set of tools, all at a fraction of the cost from the competition. So SQL 19 is kind of a proven new data platform, and what I'd like to do is spend some time drilling into kind of the major capabilities of SQL 19 that solve some of those challenges that we talked about. Consider this slide. I call this my camera slide, and I say that because a lot of times when I go through this slide in several minutes, many folks want to take a picture of it or a screenshot because it does provide a unique perspective of what are the major capabilities how SQL 19 solves modern challenges. So first of all, the concept of data virtualization and big data clusters. The fact now that you can access data from sources you never thought of before, all through T-SQL, all through SQL Server as a hub without moving the data. And in some cases, what's really amazing, without installing any drivers, which can be certainly a big pain point for customers. So we'll drill into that a little bit and talk about how you're going to access all these different icons. Second of all, we talked about the fact that SQL's on platforms never thought of before, but consider the compatibility story. Look at these icons in front of you. SQL Server, you could take a database of SQL Server, back it up on Windows, and restore it to any things I'm listing right here, even an ARM processor with Azure SQL Edge. So having the ability to build an application once and deploy it in many different platforms is a huge compelling solution for customers to solve problems they have, because many customers just don't install and deploy their applications, and their infrastructure costs just one platform. And speaking of the ability to extend something really radical, how about machine learning technologies, which SQL has done now in previous releases of major versions of SQL, but now the ability to extend it with Java, all in a secure way. We'll talk some about why that's a secure platform to run machine learning models and even Java processes with SQL Server. And if you look at the top of this screen right here, my colleague Travis Wright says, Bob, this is not your grandpa's SQL Server anymore. And what he means by that is, it's not just a SQL engine anymore. It's not just a relational engine. There are all sorts of amazing capabilities built into the product in the data platform that people just hadn't thought of before. It's a fairly radical type concept. But my colleague Pedro Lopes says, Bob, it is your grandpa's SQL Server, because you can't have all this capabilities, these new functionalities, without a true and tried engine. And so we've iterated and enhanced SQL 19 with performance, and specifically the ability of something called intelligent performance. And we'll talk some more about what do we mean by intelligent performance. You got to have a secure data platform to be successful for any enterprise. And we continue to enhance our security story with functionality like always encrypted and data classification. And then finally, there's an amazing story of availability called accelerated database recovery, and I can't wait to show you and talk about that demonstration to you. So again, look at these 6 quadrants that represent the capabilities of SQL Server. This is why it is now a data platform, not just a database engine. So let's take some time and drill into some of these and show you some demonstrations of how these capabilities can solve modern challenges for you. So first of all, we talked about data virtualization and big data clusters. And really, if you step back and find out, like, what are we trying to solve here? It's all about getting access to all of your data in an intelligent fashion. So first of all, you need to get access to all your data. So we're going to use T-SQL and a feature called Polybase to access tables called external tables, which is really just metadata, to your data, where it lives. Keep the data where it lives. That's kind of the theme of Polybase. And that could be a NoSQL system, another relational system. It could even be a Hadoop system. And in the case of big data clusters, we're going to help install Hadoop for you. So, try to standardize on a language to access data. And T-SQL, we believe, is that language. Now, it's one thing to be able to access data anywhere, but how would you like the ability to have your own data lake? How'd you like the ability to install SQL Server and us be able to deploy HDFS and Spark technologies so you can access that data either to SQL or through native interfaces with Spark and HDFS? So now you're going to be able to use Polybase to access Hadoop data, whether it's your Hadoop system or one we can deploy for you, but still access technologies like Spark, which are very important to customers in the big data landscape. And then finally, we wanted to provide a complete AI platform. Wouldn't you like to be able to build a machine learning model, like to develop it, train it, have the data available, and even expose the model as an actual application, a production application, all in one secure system using technologies like SQL Server machine learning services and even Spark machine learning? All of these together kind of provide the solutions that we believe give you intelligence over all your data. Consider this example as part of the story I'm talking about. You install SQL Server 2019, and you access all of these different data source examples I've shown right here. SQL becomes kind of your data hub. You query SQL Server, you use external tables, you put security on top of external tables in SQL Server, and behind the scenes, SQL Server, the query processing engine, knows how to go get these data and these different data sources in a very smart way. And imagine if you could join the data in all these data sources. That would be pretty cool as well. So SQL Server and Polybase become a hub for all your data accessing needs, and we're going to see some examples here of what it looks like to go in T-SQL and access type of data. You can do this right here. SQL Server Polybase is a data hub, and just installing SQL Server, whether it's Standard Edition or Enterprise Edition on Windows or Linux, you can access these type of data sources. But in SQL 19, we have provided a new solution called a big data cluster. Now, I know this architecture diagram looks pretty daunting to look at, but what it represents is a set of software components using the power of containers and Kubernetes to deploy a single solution, a secure solution using Active Directory, where you can access all the different data sources I talked about, or you can access data that we've deployed for you, what we call a storage pool, where it's got HDFS already installed and built in for you, or Spark endpoints to run Spark jobs against this data. Or you can use something called a data pool, where we'll allow you, as part of this deployment, to access a data mart, where you take offline and cached results and store that in a series of SQL instances, but you're using Polybase. You're still using the external table concept to access these things, all in a very scalable way. Or it could be that you have HDFS yourself already deployed in, say, Azure. And so we can use something like HDFS tiering to mount that into our storage pool system. So when you access this data, you're really going after a separate HDFS system. And we talked about machine learning. We have to give you machine learning languages that you know and trust and love today, and even expose these machine learning models as an application endpoint using REST. So lots of different endpoints possible, but consider this. You can go to something called the SQL Server Master Instance with T-SQL and access everything I've listed right here. A single deployment on Kubernetes using containers, using access security with Active Directory, and use a T-SQL language to access all of these different type of data sources. We'll even put in built-in availability using an integration point with availability groups already deployed for you in this solution. This is really what a big data cluster is. Balzano being a company that went during the process with us to deploy SQL 19 as we were building and shipping the product, that has been able to use this big data cluster to kind of transform how they're doing machine learning in their company, allowing to bring in access to data in a secured way, even though these data sources may or may not exist directly in the big data cluster. With that said, let's pause for a second and see some examples of what accessing data looks like in both Polybase and a big data cluster. What you're looking at right here is our tool, our new tool that we've shipped late last year, called Azure Data Studio. Azure Data Studio being an open source cross-platform tool that runs on Windows, Linux, and Mac, looks the same, feels the same in all those environments. And I'm actually, in this particular case, using something called a notebook. A notebook being something akin to, maybe you've heard of Jupyter notebooks. This is called a T-SQL notebook. And it's interesting because it's a combination of markdown text along with cells that run SQL code, kind of like a built-in documentation system for running your SQL scripts. And I'm showing you an example using Polybase to query Azure. Now, how am I even doing that? Well, with SQL 19, we have built-in drivers to access other SQL Server data sources, showing you kind of a step-by-step process of how you would go about using Polybase to access Azure SQL. And step 0 is just documentation. It just says, hey, go create yourself a database and a table in this Azure environment, and I'll show you how to query it. And when you run queries against your local SQL server, you're going to be running a query against your SQL external table, and SQL will then redirect your query to Azure to get the results. One thing I love about notebooks is the results are saved in the notebook. So I'm showing you an example execution I've already done against an Azure SQL database. Now, kind of the step-by-step process is several things. Number one, you need database security against Azure. So we encrypt it with a master key. That's the first step. And then here's where you might tell SQL Server, what are the credentials I need to access that Azure SQL database when I run queries against that data? Similar to ODBC, you kind of need a data source. Now remember, we're providing the drivers for you. So you don't need to use ODBC itself. You just tell SQL Server it's a SQL Server data source and give me the location of where that SQL Server is. In this case, it's Azure. With that data source in mind, you'll go through the process now of creating an external table. Now pay attention just for a second to this syntax. This is creating a table like a SQL Server table with column names and types and so forth, but SQL will only store the metadata inside the local SQL Server, pointing to it with that metadata, not just the column names, but the location in Azure, like what's the name of the database and the schema and the table in Azure, and what data source, in this case using Azure SQL Database. So when you run this command, you're just storing metadata. When you then query this external table, and by the way, you get to name the table, that external table name can be your table name, your semantic system in your SQL Server, not the remote table, because the remote table's right here. So I can be a different name. But when you query this, you can come through and just query it like a normal SQL table. Now we want you to be smart and run this query in a way that the query processor in SQL can potentially push down a predicate or push down a where clause, for example, to the remote system. So you get to create local statistics in the SQL Server about your remote data. Because there really are no indexes on this, because again, the data doesn't exist in SQL Server. So an example that might be just a simple where clause, or even a more complicated example might be a join. Yeah, that's the power of Polybase. I'm doing a join right here between the local SQL Server tables and the Azure SQL database, and even doing a union behind it. I could even stick a SQL view on top of this. And when anybody queries my SQL view, they have no idea where the data exists. It brings a new paradigm for accessing data. Again, that's why we call it Polybase. That's why we call it a data hub. Let's look at a different example. Over here, and I will have references at the end of this discussion where all these, you can download and run all these yourself. How about for Oracle? You're going to love this example because I'm going to show you the same type of thing of accessing a remote Oracle system, and we install all the drivers and support all the drivers to access Oracle. You don't install anything. You install SQL Server and say, I want this, and point it to an Oracle system. Notice here, it looks the same. It's the same looking syntax as I did for Azure SQL Database, except it's going against my Oracle system. Here's my Oracle data source, and I put in my specifics of my Oracle instance host and maybe listener port if that was needed. And then my external table looks just like the SQL table, except I need to tell it what's my Oracle instance, what's my Oracle schema, what's my Oracle table, but I get to name my table whatever it is. And we've got documentation. You're probably wondering by looking at this, like, how do I map up dates and how do I map up data types between SQL and Oracle? We've got all the documentation to help you do that. So here are the data types that map to remote Oracle types for the Oracle columns. And when this is done, I just query this just like I did the Azure SQL scenario. I'm querying just like a local table, and as I showed before, I can join it with a local SQL table. And to make sure I make this point clear, when you run a query against this Oracle external table, which SQL behind the scenes is redirecting to Oracle, we're not bringing in millions of rows against the Oracle table. If statistics exist and we have a appropriate where clause, we will be using the Oracle drivers to push down our predicates and only go bring back the rows we need. Now the performance is only going to be as good as the Oracle system, so you need to have proper indexing there. A great example of using both Azure SQL and Oracle. And again, that comes with SQL 19, both with Standard Edition and an Enterprise Edition. But what about this big data cluster example? Let's see a notebook of what that looks like. So here's an example from what we call the storage pool. It's going to look very similar before, but notice the data source is different. In this case, it's a special data source called SQL HDFS. That tells the SQL master instance in a big data cluster, hey, what's really going on here is the data is in HDFS, but it's in that special HDFS that gets installed with the big data cluster. So again, the syntax is very similar. But notice here, for my external table, I provide a set of columns that map to my files, in this case a CSV file in my Hadoop system, and I give it a folder instead of a file name, because that's the way HDFS works. Put a bunch of files in a folder, and we'll use scalable technology to go after all those files inside the HDFS system. And now I would go through and just query the SQL external table just like a SQL table, or join it to local SQL data. But what is happening is, in the big data cluster, the data is being redirected through the different containers and components in the pool to access that data in HDFS. So those are the examples to show you how to access data in Azure, Oracle, and even inside a big data cluster, all using the poly-based technology. In one case, you'd be deploying it yourself. In this case, with a big data cluster, all deployed for you. Okay, that is data virtualization in big data clusters. Well, we talked before about platform of choice and compatibility, that SQL Server can run in many different platforms. In fact, a big data cluster being a great example where SQL is pre-deployed with a bunch of other types of software components using Kubernetes in a containerized environment. But SQL itself is supported in all these different platforms you see, whether it be Windows, which we have done for many different years with SQL Server. We've been doing SQL Server on Linux since SQL 2017, and we continue that tradition, supporting new environments, for example, like Red Hat OpenShift. And one of the things we noticed with SQL Linux is that customers saw the great compatibility that we had. Remember, I talked about that database restore scenario, but there were some features on what I call the edge of the engine, like replication or distributed transactions, that we did not support with SQL Linux that were supported on Windows, and all of that now works on Linux. For containers, we still believe containers are a big future of how you deploy and use SQL Server. So you notice here, we now support the Microsoft Container Registry, where we put all our container images in a very secure way. We support Red Hat images now with SQL 19, and to ensure that we're supported in environments like OpenShift, we support by default non-root containers so that the SQL Server container doesn't run as root permissions in a containerized environment. So for SQL Linux, we have customers that are being very successful with this platform, and Team System is one of them. Team System being an ERP software manufacturer that is a leader in this area in Italy, and they have pivoted to use SQL on Linux. Well, what they've done and found is a very successful way to run SQL on Linux in Azure, using Azure virtual machines, taking advantage of SQL Linux because they wanted to use Ubuntu as a platform to run SQL Server, but they wanted that hosting infrastructure that Azure VM uniquely provides. So I also mentioned before the fact that we support machine learning and extensibility. And we have other enhancements for developers like Graph and UTF-8 support. But look at this diagram for a second, because I've had several customers talk to me that they're very uncomfortable running a Python script model or an R model or even these Java extensions in SQL Server. This model shows you about a secure, isolated, and governed environment to run this. If you look at this, all access to any of these Python, R, or Java programs first have to be deployed as a feature. So you have to be an admin to deploy the feature. They have to be enabled with SPconfigure. Access to them only happens through T-SQL, which has to be granted with a secure model. So out of the gate, nobody can just run this stuff. Administrators have full control and decide what can be run and when it can be run. But even when it's executed, there are processes that run these scripts and programs not in the SQL process, but in a low-privilege, isolated model on the same computer as SQL Server, whether that be Linux or Windows. And then, most importantly, Resource Governor is tied into this environment. So you can use Resource Governor to go in and control CPU, memory, and even affinitization to how our Python and Java programs run in conjunction with SQL Server. This is a very scalable, secure way to start running machine learning models and even be able to extend the T-SQL language with Java. And Systems Imagination is a company that has been able to take advantage of machine learning at scale because they've been able to run their models now on the same server, which is a lot of horsepower, with SQL Server itself. Now, we mentioned before that performance, security, and availability are still very critical to running SQL Server environments, and all the things I've shown you so far are not possible without that. And so we've made some great enhancements into SQL 19, not just to make SQL fast, but to keep you fast and to enhance your performance with no application changes. The other thing we've done is try to give you great insight into performance scenarios to reduce the time it takes you to tune queries. So for example, we have lightweight query profiling turned on by default now with SQL 19. You can walk up to any SQL server and see a query in flight at the query plan level. You can see the progress of row counts on any active query running on your SQL server. In addition, we've enhanced the SQL Server query processor, the built-in query processor of the engine, in a concept we call intelligent query processing. It's not a feature. It's just built into the query processor. You move to the latest compat level of SQL Server, and we light up the query processor in a way that wasn't possible before. In fact, we wanted to build a query processor that could adapt to your workload versus you adapting yourself, having to put in a bunch of query hints and so forth. And Bank of Tao is a customer that did this. We were working with them in SQL 19, and they upgraded. They did a test of upgrading 19 in their test environment, went to the latest compat level, and saw this major improvement in performance. And they didn't understand it. In fact, they were kind of nervous about this, like, what happened? So they contacted us, and we showed them by looking at query plan results between compat levels, database compat levels, how intelligent query processing was doing things very unique, like lighting up batch mode for row store, or improving table variable deferred compilation scenarios. Some of those kind of type scenarios that had problems for them in the past now became faster, and they made no code changes to make this happen. So intelligent query processing, lightweight query profiling are great examples of how we've improved the performance of SQL Server in a new and unique way. And think about what we're trying to do here. We're trying to build a very adaptive engine for performance for your code. We don't want you to spend as much time having to do expensive query tuning or put in a lot of query hints or do a lot of testing with what happens with upgrades to the new versions of SQL Server. And you're going to see me towards the end of this presentation talk a little bit more about what we've done to help make database compatibility a new paradigm for you to certify your applications. So here is intelligent performance. By the way, you see in this diagram as well that query store is still part of that story. It's interesting because I've had customers that I've talked about SQL 19 when I mentioned them about looking at query performance in a new and unique way. And I say, hey, query store is still a great thing for you to use, just like we had in SQL 16. And no fault to those customers. They're like, what's query store? So query store has been around since SQL 16. But remember, that is a built-in capability into the database engine to get great query performance information inside your database stored, and it's persistent across server restarts. So instead of polling DMVs, you're using an actual set of data to look at performance statistics. And all sorts of scenarios are lit up now with query store. And we'll talk a little bit more about that as we talk about migration. So if you think about performance, certainly one of the areas you have to think about is security. You cannot have an enterprise credible data platform without a secure system. And we pride ourselves in the features we put into security in SQL Server throughout these various releases up to SQL 19. But in SQL 19, we've also enhanced the always encrypted feature of SQL Server to include the concept of secure enclaves. No longer does the application have to be the only part of the process to look at unencrypted data. The data is still encrypted across the entire process between app, middle tiers, SQL Server, but now you can take advantage of secure enclave technology, whether it be virtualized or built into hardware chips, where now an encryption happens in the enclave on the server, making this process much faster and lighting up new scenarios where certain situations where you couldn't even use an index now can be done because we're using secure enclave technology. So, Hiscox is a customer that because of what we've done with secure enclaves, we're able to now use always encrypted in a way for their applications. They felt much more comfortable that they had a complete end-to-end encryption story, and enclaves opened up some of the limitations that they couldn't use that technology previously. Data classification has been a technology that we've offered from our tools that we had in SQL 17. Now with SQL 19 and also in Azure, we've put classification in the engine. So T-SQL syntax now is supported to classify and label your columns of your tables. The tools will give you suggestions, but you have full control now to classify your data, and we'll store that in actual system tables so you can query and see what kind of my columns are. Some customers, for example, in Europe, with GDPR qualification compliance, have chosen to use GDPR labels with their columns. But it's not just about classification. It's also about being able to audit what's been classified. So now you can classify your columns with T-SQL, and then if you touch or select a classified column, SQL Server Audit can now detect that and flag that a classified column was queried by a user. Now you get information about what user, what time, what scope. So it kind of rounds out the whole classification story to give you auditing with it. We continue to enhance technologies like transparent data encryption and even making certificate management simpler for you. So that's kind of a little bit of a summary of what we've done from a security perspective. And if you think about performance and security, one other area that might be important to you is availability. And think about this story. It's a classic story I've seen throughout my career at Microsoft. I've been at Microsoft for 26 years, and this story hasn't changed. And that is somebody run a very long transaction, long-running transaction, like do a transaction and delete 1 billion rows. And then somebody comes along as an administrator and realizes that the entire business is down because this transaction is blocking everyone. So they try to kill the session associated with this transaction to have it rolled back. Well, because of transaction consistency, we have to wait for that rollback to complete, and that could take a while. So the app is still down during this process. The transaction log is now growing out of control because you cannot truncate active transactions. So then somebody may even come along and think they're clever and say, well, if I just shut down SQL Server and restart it, it'll magically just come back up, which it will come back up and be consistent, but we still have to undo or roll back that large delete, and the business and the database is still unavailable. So what's the answer to that? Obviously you can try to do things to prevent people from doing long transactions, but wouldn't it be nice if you were not beholden to long active transactions? And so accelerated database recovery is a new technology. Banco Itaú is a customer that's also taking advantage of that to keep your database highly available. A lot of people that have heard about this technology think, wow, that's just too good to be true. There's got to be some catch to this. And there are some requirements to use accelerated database recovery. It's a database option. Behind the scenes, we use a persistent version store. It's not the same version store in TempDB. It's a similar technology. But this version store is used specifically to track versions for recovery purposes. And in fact, it's independent of locking and isolation levels, so we still support all the locking and isolation levels. It's just that the version store is persisted in the database, not in TempDB, which is how we can now use it during rollback and recovery scenarios. Rollback is crazy fast. Undo recovery becomes extremely fast, and transaction log truncation now is not beholden to active transactions. Now, you're going to have some questions like, how does this affect performance? Does the database have to grow because of this? And all of those are true statements. You're going to see a performance impact in some way potentially. The database is going to require more space for this version store. Fortunately for you, we have a very detailed white paper that I love to read because it shows experimentation results from our engineering team when we built this technology for Azure, and it shows you the possible impact to your application depending on how many changes you make, how long you need versions, and how large the versions need to be kept around in your database. So I have found that customers have been able to use this technology, depending again on the type of app, and they've not seen a lot of big performance implications from this or large growth problems, and so it's been very viable for them to turn this on. And in fact, we use this technology in hyperscale. Hyperscale in Azure is the technology that is, quite frankly, one of the ways it's been able to be successful is because behind the scenes we use accelerated database recovery. And in fact, one question I get is that, does this work with an availability group? It doesn't just work with an availability group, it makes availability groups amazing because read-only replicas are now using the persistent version store on the replica. And then think about the failover that occurs to a highly available availability group. We're always forwarding transactions on that secondary replica, but now when you fail over, you have to run the undo recovery. Well, that happens very quickly now because you're using a persistent version store. And in fact, I'm sure you want to see this in action. So let's show a demonstration of this. Now what you're looking here is, again, another T-SQL notebook. In this particular case, it's an example of accelerated database recovery. And again, I told you about a T-SQL notebook. It's got markdown text, it's got code in it, but the results are safe. So I'm showing you an example where I ran a successful scenario showing the speed of rollback and also the benefit of log truncation with and without accelerated database recovery. In this example here, I made the database simple recovery because it's easier to show log truncation in that scenario. So this is a very simple database. I'm just putting in about a certain number of 100,000 rows in the database. So it's not going to show a major difference, but it kind of gives you an idea of how faster things can be with accelerated database recovery. So first of all, I'm going to go start a transaction and delete all these 100,000 rows, but I'm going to leave the transaction active. And this is without accelerated database recovery. When I do that, you'll notice that the transaction log has about 91% space used in the log at this point. Now that makes sense because there's an active transaction up there. We cannot truncate the log even with simple recovery. We can't truncate this thing because of the active transaction. In fact, if I manually try to checkpoint the database, which is a common thing that people do if they can't truncate the log, you'll notice here it's still 79% used. Again, we have the active transaction. For consistency reasons, we cannot truncate the log past that active transaction. So I can go back and do a rollback. In this case, it takes about 11 seconds. And then I can go back and look at the spaces of the usage of the log space of the transaction and see, finally it's cleared up. It's like 1%. This makes sense, right? I've got a simple recovery database. I finally roll back my transaction. But even in this case, notice that for 11 seconds, we were down, in my environment. For 11 seconds, we were blocked. The log couldn't be truncated. Imagine if this was like a billion rows, right? For a long active transaction, you could be down for minutes or even hours, which could be critical to your business. So let's see what it looks like for accelerated database recovery being on. So I'll turn it on in this T-SQL cell. It's already executed and it's running. And then I'll do the same thing. I'll just delete the transaction. Notice it only took like 3 seconds. That's just because of what we're having to do to log things are going to be slightly different in this model with accelerated database recovery. Now I'm going to go look at my log space usage before and after checkpoint just to show you I don't need the checkpoint. Notice it's 20% used without a checkpoint. That's because with accelerated database recovery, we're using a persistent version store, and we're not beholden now to that active transaction. And in fact, when I truncate it, I do get down to like 7%. So a lot less log usage, a lot less worry about log growing out of control, all because of this persistent version store. Now, you may be wondering, like, how fast is rollback? And you see here, I kind of tease everyone when I show this, and I ask the audiences all the time, like, how fast do you think this was? It took like 11 seconds before. Well, look how fast it is. It takes even less than a millisecond to roll this back. That's because we're not recording compensation records in the log to roll back. We're just marking the transaction being aborted. One other quick example to show you the power of this. This is a more advanced scenario using accelerated database recovery, where I'm doing the same thing. The only difference here is I'm going to show the shutdown problem. So imagine in the same scenario where you go down here and you checkpoint your database and then you crash SQL Server. So you want to go back and look at recovery. So here's an example of what an error log looks like. Let's go see here, error log.no ADR. This is an error log example where I had to shut down SQL Server, but ADR was not enabled. So if I scroll down here to the very bottom, you're used to probably seeing these percentages of recovery for a given database. And you can see here that here's the recovery phases of the database happening, and it says like 3%. So, who knows if this is really long? This could be a very long period of time. In the end, the recovery finished, and it took, it took about 50 seconds to recover the database. Not that long. 50 seconds still could be a long time for your business. But again, if it was a huge transaction, this could be in terms of hours. What about an error log where you're using accelerated database recovery? You might be asking yourself, like, well, maybe the phases are faster. Maybe it's less than 50 seconds. I really don't know how fast it is. Let's go take a look at what that looks like. So let's bring up this error log. And if you scroll down and look at this error log, you may be looking for the phases of recovery. I know there's a lot in the error log to be scrolling through here, but let's just see here, right here. You can see that we rolled back a transaction and we're writing a checkpoint, but we didn't even write the phases of recovery. We were so fast to recover the database in seconds, we didn't even bother trying to print out the phases of recovery for this database. That's how incredibly fast this can be. And again, imagine if this database was part of a failover partner. So failover happens very, very quickly. And again, that's why accelerated database recovery was one of the technology that powers hyperscale. ADR, which is what we call this technology effectively, is a database option you turn on or off with SQL 19, and it's on by default in Azure SQL Database and Managed Instance, including hyperscale. So we've shown you the power of the capabilities of SQL 19, and you're going to be amazed by this. Those capabilities are in Standard Edition of SQL Server. In fact, we're going to show you a little bit of a chart to show you some of the new things that we've added to Standard Edition. But first of all, you might want to migrate. So we have tools for you. We have tools to assess your migration and try to figure out what kind of problems you might run into to migrate to SQL 19. We have tools like Database Experimentation Assistant to evaluate your performance. We even have tools called Database Tuning Assistant in Management Studio to use Query Store to evaluate your performance after you've migrated to help tune it. So we have all the tools we think you need to go through the process of migrating to SQL 19. Now, in addition, I mentioned about database compatibility earlier in this discussion. It's our belief that software vendors, we've had some of them do that already, including SharePoint, or in-house application developers can start certifying their application on a database compatibility level of SQL Server and not a version of SQL Server. And this is because the engineering team is putting their teeth behind this and saying, hey, we think that if you run all the right tools and look at all the possible problems and you mitigate all that, you're not going to run into problems when you make this migration, including query plans. The shape of a query plan being what operators are used to produce a query plan, that will not change as long as you stay with the compat level that matches your older version of SQL Server. So you make this move. You go from SQL 2008 R2, for example. You go to SQL 19. You keep the compat level that matches SQL 2008 R2, and then you move and run your production application. Now, in that particular case, you can take advantage of something like accelerated database recovery because it's not tied to a database compat level. But when you're ready to make that move to the latest compat level and take advantage of intelligent query processing, you can use something like Query Store to evaluate what will my performance look like between compat level changes. Now, as I mentioned, SQL Server Standard Edition covers a lot of stuff I talked about today. And we made a change in SQL 16 SP1 to bring up features like column store, for example, so that the surface area for developers was the same across editions. That way you can write your app one time. But in SQL 19, we've enhanced features in Standard Edition, including enabling big data clusters, polybase, accelerated database recovery, and even transparent data encryption to ensure that you get the features you need to run a Standard Edition application. There are going to be reasons you might need to use Enterprise to go to a full Enterprise edition of SQL Server, but we wanted to make sure you understood that Standard Edition comes with many great functionalities that could meet the needs of your application. Now, it's not just a technology discussion. It's all about licensing as well. And so a lot of people don't realize the benefits of using SQL Server with software assurance. Whether it's with Standard and Enterprise to take advantage of deploying SQL Server on big data clusters, or the fact that you get free licenses of running SQL Server in failover environments with Standard and Enterprise. And we've got some, in just a second, I'm going to talk about some new functionality we've added from a licensing perspective. But you see here, there could be reasons you need to Enterprise, whether it's unlimited virtualization or machine learning server or even Power BI report server or a higher scaled version of a big data cluster. Enterprise may be the choice for you. But Standard Edition, as long as you're using software assurance, has a lot of great capabilities from a licensing perspective that you may not be aware of, but you need that software assurance to take advantage of it. And in fact, one of the new announcements we made recently was the fact that previously with software assurance, you had to have what's called a choice to decide to get that free passive instance. What I mean by passive is that you don't actively use it as a SQL instance for, say, high availability. We use like a sync replica. Or disaster recovery, we have like an async replica. You had to make a choice. Now, our new software assurance policy, even with Standard Edition, allows you to do both. You can have a free version, a free license of SQL Server to use as a passive instance for high availability purposes, and also for disaster recovery purposes. And what's also exciting is one of those disaster recovery instances can be running in Azure. So imagine you now, with software assurance and Standard Edition, having access now to the ability to not have to pay for licenses for SQL on what we call a passive instance running in your environment on separate servers or in the cloud, whether that be for high availability or for disaster recovery.